The next is the problem statement, which is the first problem statement is a plastic straw, a common item in the coastal litter, only represent a small fraction of annual plastic waste. Banning straw has shown minimal impact and on the plastic waste volume, as seen in Hong Kong, raising the question about its effective in addressing plastic pollution. And the second problem statement is a single-use plastics contribute to waterway pollution with initiatives like the Sound Shore Last Straw campaigns aiming to the reduce straw use and raising awareness and promoting behavioral change are crucial for reducing plastic waste. And the third problem statement, straw, a common household item, are facing anti-straw campaigns due to concern about the germ and plastic pollution. Despite being a small fraction of the ocean plastic, straw pose a significant threat to marine animal and fish consumption.
Okay, next for the evaluation of alternative. So our objective, we have three objectives. So for the first objective is to produce of edible straw from tuber plants like sweet potato, and tapioca. So for the second objective is to testing and comparison of our straws with rice straw to assess their effectiveness and usability. So our last objective will be to determine the collection data and analyze the result, aiming for durability, functionality, degradation, and environmental friendliness.
So next is idea, novelty, and creativity. First, our product has a new concept which is used a lot and renewable tuber plants like potato, sweet potato, and tapioca. It is to create the biodegradable straw and providing eco-friendly alternative to plastic, because nowadays plastic gives some negativity to environment and our flora and fauna. So it's better than our product which is biodegradable straw to environment, more safer, more secure. And second, we has innovative material choices, which is our tuber plants offer natural starches, natural leaf and fiber that break down quickly in environment, making them a superior choice over traditional plastic, even other plant-based material. So our third point is disruptive innovation. So our product are solution not only a lower production cost but also introduce a novel method of reducing plastic waste, and it also targeting a both eco-consumer and cost-sensitive market, disrupting the plastic straw industry by offering sustainable and affordable alternative. And the last point, which is our product is an unexpected impact. So tapping into the untapped agricultural resources, this innovation open a new economic opportunity in the agriculture sector while offering a high-performance biodegradable products exceed expectation in environmental impact. So as long as our product still produce, it can help more environment to become healthy. So next, I'm gonna talk about the implementation engineering plus level of research. So our studies investigate food straw made from potato, sweet potato, and tapioca. So we aim that to reducing the environmental impact of daily non-degradable waste collection, which is focusing on the production, testing, and the potential use of the edible straw. Our product, renewable material, offer that a promising alternative in line of the green construction, which is SDG 12 and 14. The research explore the use of edible straw as a sustainable alternative to traditional plastic. So in line of principle of responsible use of production and a life underwater, which is edible straw reduce plastic straw and contribute economy by single-use item into the disposable. So our product that you can improve the quality of the environment. The straw also has a complex mechanism, so engineers need to find the problem and solve it.
So next, for product description, detailed project, we blend of all the ingredients such as wheat flour, tapioca flour, water to create a biodegradable and sustainable alternative to traditional plastic straw. The specific dimension of the biodegradable straw include the length of 19 to 20 cm, an internal diameter of 6.5 to 7 mm, and a thickness of 1 to 2 mm and a weight with 12 to 20 grams. By combining this natural ingredient, the edible straw aims to provide a safe and eco-friendly option to consumer, addressing the environmental concern associated with plastic pollution.
Okay, I will be continue about the photo and detail of project. The first, we peel the skin of the cassava, potatoes, and sweet potatoes, and then we grate the sweet potato until it becomes pulp, and then we filter the scum until the scum water content is 50%, and we weigh the 13 gram of the wheat flour and the 27 gram of the cassava flour. We will continue with the mix the cassava and the wheat flour with the sifted rice, and then mix the ingredient and make a mixture. Take the mixture and place it in the plastic wrap and flatten in using a roller until the surface take the 0.1 cm. And then we put the ingredient in the steamer, then steam for 20 minutes. After that, we remove the mold material and dry it in the sun, under the sun for 50 minutes. And take a straw as a mold, roll it on the mixture until it form a straw. And then the finishing and the drying the straw model under the sun for the drying process. The next, the product demonstrate. The left figure is the ongoing test, and the right figure is the after being tested and with data. The image showcases a product test and evaluation process with the item submerged in the transparent container to assess the performance and durability. Results are displayed after the testing, with the comparison showing change in the physical appearance, structure, or quality. The close-up view reveals degradation of wear. Quantitative analysis is used to provide insight into performance.
So next, our product that we're gonna do is a product demonstration. So first we do the table moisture absorption, which is we're gonna use drinking water at the 32 degrees Celsius. For the temperature, it's room temperature. It's good for our testing. So we can see that graph, which is weight versus time. So after that, we can analyze the graph. We also show that in the table. So the type of straw that we produce, which is potato, tapioca, and sweet potato, right? So we compare it also with the commercial straw as a control, which is 10 gram in our initial weight. So potato, it has 21 gram, tapioca 20 gram, sweet potato also has 21 gram for the initial weight. So we gonna put that initial weight into our moisture absorption calculation, which is our formula, and final mass minus initial mass divide by initial mass multiply 1000. So after that, we are gonna get the water absorption for the potato is 52%, tapioca 58%, sweet potato 55%, and our standard control is 98%. So we find that the lower straw, it goes the good result. So we find that the potato is the best moist water absorption than the others because it's absorb less than them. So we're gonna go with the moisture absorption, but it's a different temperature.
So for the next testing for water absorption is we will test it in a cold water with 6 degrees Celsius. So for the initial weight for all 3 straw is 16.321 gram for potato and 12.597 gram for tapioca, 18.228 gram for sweet potato, and 5.855 gram for our commercial straw for control. So after 60 minutes, you can see for potato, it already absorbed 41%, and tapioca 49%, 46% for sweet potato, and 75% for commercial straw. After 60 minutes, the weight is 23.049 gram for potato and 18.889 gram for tapioca, 26.781 gram for sweet potato, and 10.301 gram for for commercial straw.
Alright, so next we are gonna talk about the product demonstration for our biodegradable test for the tuber plants. So this is our pictorial report that from day 1 to day 32. So first we have type of straw. Our straw is a potato, tapioca and a sweet potato. So we compare it with the commercial straw, which is Zeus coffee straw, as a control. So for the day 1, we find that the straw, we just put it inside the aquarium for the test. It still look fresh and nothing has changed much. So for the next day, day 6, it seems like it start to react with moisture and the first signs of fungus appear. So on the day 12 and the day 18, the looks similar. It looks curry red, and the composting process just getting started. For the next day, which is day 24, we find that the straw, the overall straw look crushed and composed, and also mixed with the soil. So while describing this process, we weigh the initial and final weight only to get the percentage of decomposition. So as you can see, for the potato, percentage decomposition that we get after day 32 is 78, and tapioca has 48%, sweet potato 68%, commercial straw has a 32%. So it describing the higher percentage is a good one. It's a good for our testing. It's good for our product, for environment. So yeah.
So for the impact on society and or professional practice, for environmental impact, if the products made from tuber plants and it can break down easily, reducing the long-term environmental waste.
The next is a society impact, which is that we promoting the tuber plant-based product could create the new opportunities for farmer and rural communities, which we provide the opportunities and increase the income of farmers.
So for the last one is professional practice impact. So our product encourage collaboration between agriculture, material science and manufacturing factory. So this collaboration opportunity promote a teamwork between the farmer, material scientist, manufacturer to produce eco-friendly straw from tuber plants.
Last but not least, for the marketability, this project showcases entrepreneurial potential by use of tuber plants, a resource in food and beverage industry sector, sustainability and environment impact, circular economy and composting. Marketing potential lies in the offering eco-friendly, cost-effective and environmental solution. So for one straw, for potato we can get 22 cents, and for sweet potato we can get 24 cents per piece, and for tapioca we can get 30 cents per piece. So that's all from us. Thank you.